Okay, today we're going to deal with 7.7 adding and subtracting polynomials. Just as you can perform operations on numbers, you can perform operations on polynomials. To add or subtract polynomials, combine the like terms, just as we've been doing for chapters now. So let's take a look at our first examples. We're going to add 12p to the third plus 11p squared plus 8p to the third. And the like terms that I'm going to be looking for are the exponents on my variables. So my two like terms in this first expression are the 12p to the third and 8p to the third. I can't combine it with 11p squared. That's a different exponent. So I'm going to put my like terms together and then just add or subtract my coefficients according to the signs. So my final answer is 20p to the third plus 11p squared. So on your second example, let's identify again my like terms. 5x squared minus 6x minus 3x plus 8. Sorry, just minus 6. My first term has x squared. My third term has x. Those aren't like terms. Minus 6 and plus 8 are constant terms. They're the same. So let's rearrange it so that they're together. Again, let's put it at the end of the expression so that it's written in the correct form, in standard form. So after I do plus 8 minus 6, I end up with 2. 5x squared minus 3x plus 2 is my final answer. Okay, a couple more examples. T squared plus 2s squared minus 4t squared minus s squared. I have two different variables in this example. So I'm going to check my t's and see if they have the same exponent, and they do. I'm also going to check my s's and see if they have the same exponent, and they do. So let's rearrange this with my like terms and put them together. Now that I have my t's together and my s's together, let's go ahead and combine them. Remember when you rearrange these with like terms that your plus or minus sign stays with that coefficient. So t squared minus 4t squared is negative 3t squared. 2s squared minus 1s squared is s squared. Last one, I've got m squared n, and m squared n. Those have more than one variable, but it's the same combination of exponents to variable ratio. So those are technically all like terms. So now I just have to add and subtract my coefficients out in front. 10 plus 4 minus 8. So 14 minus 8 is 6. And that's the answer. You're done. So remember, like terms are constants or terms with the same variables raised to the same powers. So we learned this all the way back in Chapter 1. If you want to go back and review, look at Chapter 1, Section 7. Okay, polynomials can be added either vertical or horizontal form. I like to put mine into vertical form, but the book will give you examples in horizontal form, and you might change them into vertical form. So in a vertical form, align your terms and add or subtract. Okay, so if we add them, we don't have to worry about sign changes and that kind of stuff. So for example, 5x squared plus 4x plus 1, if I have a second trinomial with those same terms of an x squared, an x to the first, and a constant term, I can just add them up and combine my coefficients out in front. In horizontal form, you're going to want to regroup using associative and commutative properties to get them alike, just like we were doing before when we were rearranging the expressions. So when you have two trinomials, you're going to identify your like terms, which you should have 3 groups of same terms, and then just combine your coefficients again. Okay, so let's give this a try. 4m squared plus 5, that is a quadratic binomial, plus m squared minus m plus 6, again a quadratic trinomial this time. So let's find our like terms using our associative and commutative properties. I've got m squareds and I've got constant terms. My minus m in my second trinomial or second polynomial doesn't have another like term, so it's going to just stay minus m. So let's go ahead and combine my m squareds and my constant terms. 4m squared plus m squared is going to be 5m squared. That minus m, it stays in the middle, and 5 plus 6 is 11. That's your final answer. Box that. Second example, I've got 10xy, and if I look in my second polynomial, I've got minus 3xy. Those are alike. In my first one I have x, and my second one I have y. Those are unlike. Those will just hang out by themselves. So let's rearrange it. I've got 10xy minus 3xy plus x plus y at the end. 10 minus 3 is 7. That's your final answer. Go ahead and box that. Okay, I've got some examples. I want you guys to maybe pause it and work through the next two examples, example 2C and example 2B. So hopefully you got those correct answers and you worked through them on your own. Okay, subtracting polynomials. For some reason it's a little bit more difficult for us. Addition is always easier for us. Subtraction, we have to kind of think opposites, and it's more difficult. So remember that subtracting is the same as adding the opposite. To find the opposite of a polynomial, you must write the opposite of each term in the polynomial. So you just take that minus sign to subtract on the outside and you distribute it to each term on the inside. So let's go ahead and give this a try. I've got x cubed plus 4y minus 2x cubed. I still need to identify my like terms. Okay, distribute that negative through and identify my like terms. So I've got x cubed and I've got negative 2x cubed that are alike. So if I put those together, 1 minus 2 is negative 1. Remember, we don't write the 1 in there. Okay? Bigger polynomials this time. 7m to the 4th minus 2m squared minus 5m to the 4th minus 5m squared plus 8. Let's distribute that negative. Okay, so I've changed all of the signs inside my second polynomial. You notice it's just opposite signs when you distribute a negative. And now I can look for my like terms. I've got m to the 4ths and I've got m squared. My minus 8 all alone is going to hang out at the end. So let's rearrange it to group them. Sorry, I don't know how to move the box. You guys are going to have to just deal with that. 7m to the 4th minus 5m squared. Negative 2m squared plus 5m squared. Remember that negative 2m squared from my first polynomial, that minus 2 stays with it. And now if I just perform the operations on my coefficients, I find out my final answer is 2m to the 4th plus 3m squared minus 8. Okay, last example. Go ahead and pause and give it a try. Okay, so hopefully you got that same answer. Okay, where are we going to use this in the real world? A farmer must add the areas of 2 plots of land to determine the amount of seed to plant. The area of plot A can be represented by 3x squared plus 7x minus 5, and the area of plot B can be represented by 5x squared minus 4x plus 11. Write a polynomial that represents the total area of both plots of land. So I need to combine these two polynomials. So if I just write them out, I write them vertically. It's so much easier to me to not have to regroup, but to already have like terms aligned. So let's add these together. 8x squared plus 3x plus 6. Okay, where else might I use this in the real world? The profits of 2 different manufacturing plants can be modeled as shown, where x is the number of units produced at each plant. Okay, so this is like an industrial or business application. Use the information above to write a polynomial that represents the total profits from both plants. So I've got the eastern plant and the southern plant, and they give me the polynomials there. So let's go ahead and write those out. And I'm going to do it vertically and align them vertically because it's so much easier to me combine this way and not have to rewrite it. So then just go ahead and add those things together, and I've got my final answer. Negative 0.05x squared plus 46x minus 3,200. If a decimal is given in the problem, your final answer should have a decimal. Remember, if a fraction is given in the problem, your final answer should have a fraction. Alright, you guys have the lesson quiz part. I don't have answers for that. Give it a try and bring it in tomorrow to show me.